Good morning to everyone. I am Francesco Meini and work in the Development, European Programs and Innovation Department of the Port Network Authority of the North Mediterranean Sea, namely work for the Port of Livorno. My presentation will be about the MEDECA implementation regarding alternative fuels. Are med ports ready? And I will show you the experience of the ports of Livorno on alternative fuels, namely hydrogen. The key points of my presentation are the following. First of all, I will talk about the role of green hydrogen in the energy transition, the European objectives and policies for supporting the hydrogen supply chain development, hydrogen carriers, port readiness for the hydrogen transition, and then the Livorno port experience. The energy transition from fossil fuels to renewables is widely considered as a key action field in decarbonizing the global economy, thus preventing the irreversible consequences of climate change, too well known to all. As we can see from the picture, the greatest part of the required energy in the coming decade will still come from fossil fuels. Fortunately, however, renewable energy sources will see the highest growth from 2030 on. This is the global energy mix developed by the European Commission, and we can see that in 2050 fossil fuels and natural gas will be nearly zero. But today I will focus my presentation on hydrogen. As you know, three are the main types of hydrogen. We have green hydrogen, which can be obtained using a process of steam methane reforming, where natural gas is mixed with very hot steam. Blue hydrogen is also produced from natural gas, but the CO2 is captured and stored. And then green hydrogen is obtained via electrolysis, that is, the use of renewable electricity to split water into hydrogen and oxygen. But why is green hydrogen so relevant? First of all, it has no carbon impact, since the energy used for electrolysis comes from renewable sources. The use of green hydrogen as a raw material and fuel can reduce emissions in industry and make a major contribution to the 2030 and 2050 climate targets. And in addition, when solar and wind energy sources are largely available, renewable hydrogen can support the electricity sector, providing long-term and large-scale storage and improve the flexibility of the systems. The focus on green hydrogen is today visible in both private and public sectors, so there has been a growing strong regulatory and political support, particularly in Europe. In the recent years, the European Union has launched different support mechanisms for hydrogen initiatives and projects. The Clean Hydrogen Partnership, which awarded the North Iranian port system as a certified green hydrogen valley, is a partnership supported by the European Commission in order to accelerate the development and improvement of advanced clean hydrogen application. The European Clean Hydrogen Alliance has been created to support the large-scale deployment of clean hydrogen technologies by 2030 by bringing together all renewable and low-carbon hydrogen supply chain phases. As a financial instrument, we have the European Hydrogen Bank, which is devoted to unlock private investments in hydrogen value chains, both within the EU and globally, by connecting renewable energy supply to European demand and addressing the initial investment challenges. As a local, green hydrogen production in Europe is not expected to be sufficient to meet demand. Hydrogen transport over long distance will be necessary. Most of the available techniques to do this require the conversion of wind and solar energy to hydrogen carriers in or near the exporting port, and the transport of a suitable hydrogen carrier to importing areas. The most commonly considered hydrogen supply chains include liquid hydrogen, compressed hydrogen, ammonia, and organic hydrogen carriers. Hydrogen can be transported in liquid form at an extremely low temperature in its pure form, but cooling to below 2253 degrees consumes a lot of energy. Hydrogen can also be compressed in hydrogen tanks at a very high pressure to have compressed hydrogen. Hydrogen can be packed in ammonia, which is obtained reacting hydrogen with nitrogen, and then hydrogen can be transported by coupling it into other liquid organic hydrogen carriers. These are organic compounds that can absorb and release hydrogen through chemical reaction. These processes lead to various possible green hydrogen value chains. So investigating the technical and economical feasibility of such value chain solution is crucial for the sustainable development of hydrogen-based energy production and consumption. The search for the cheapest way to produce and transport hydrogen has intensified, entailing key questions such as from what distance is it worth to transporting via ships, when could pipelines be used, and in which form are we going to transport hydrogen? And also, why and when can we avoid conversion again, and so on. But are ports ready to meet such transition? The cost of hydrogen production is going down thanks to the investments being made, the long-term trend of decreasing costs of wind and solar power, and expected longer-term price increases of fossil fuels. A key factor in bringing green hydrogen costs down, ensuring its availability on a large scale, is scalability. Mobilizing investments to scale up the production of green hydrogen will require continued efforts towards more international collaboration to shape policy, regional and multilateral agreements and supportive frameworks from regulatory bodies. In this picture are shown the requirements that seaports have to take into account when it comes to scalability. Infrastructure, for example, the production and storage of green hydrogen requires large surfaces. This challenges ports to make enough land available for production and storage activities. Land areas required for electrolyzers and related equipment such as transformers, rectifiers, water supply, cooling water towers, separators, dryers, compressors, and so on. Connectivity to electricity grid and H2 assets in some part of Europe. High voltage grid operator can no longer guarantee that new wind turbines, solar parks, or power station can always put their power on the grid. Demand. Quite a number of larger seaports have developed into major industrial and logistics ecosystems and are well connected to the other industrial clusters in proximity. Public acceptance, with the not in my backyard issue, lack of standards and regulation addressed by many ongoing projects, and last but not least, the risk to be considered when it comes to handle such elements. So how to overcome such challenges? Ports have to investigate the technical and economical feasibility of such value chains solution because it is crucial for the sustainable development of hydrogen-based energy production and consumption. In addition, there is uncertainty on the preferred hydrogen carrier regarding rules and regulations, safety standards and certification, and the impact that this will have on hydrogen supply chains. So only by testing we could launch pilot initiatives and demonstrators which are triggers for the development of green hydrogen bunkering import-export functions. These actions in this direction must follow an idea of port authorities cooperation. Great challenges require great partnerships, collaboration and responsibility. We have to enhance connections between the EU and neighboring Mediterranean countries by sharing knowledge, resources, and best practices to achieve greater environmental sustainability. This is the way that we, as Port of Livorno, are following. As said before, local green hydrogen production in Europe is not expected to be sufficient to meet demand, so hydrogen transport over long distance will be necessary. In addition, in Europe there is no distribution network for hydrogen, so we decided to undertake a technical, administrative and economic preliminary study for the creation of a Mediterranean supply chain for liquid hydrogen based on export hubs in third countries and on import hubs for the cooperation area. We are developing this project with the University of Pisa, the Arab Academy for Science, Technology and Maritime Transport, and the maritime transport sector from Egypt. The project is composed of 3 work packages, which are replicated on both sides of the Mediterranean and of the partnership. So Italy will make the preliminary investigation and technical economical analysis on its side, and Egypt will do the same on its side. But why are we doing this? We think that each stakeholder at each stage should be involved in the definition on every steps to be taken And if stakeholders participate in the requirements definition phase and will get involved in every step forward, this will lead to a validation by design paradigm for evaluation of feasibility and replicability. On that basis, knowledge is created, but is nothing without sharing. Here comes the ambition to share information, knowledge, best practices, screening tool to be continuous enriching aim of each initiative. Thank you for your attention and do not hesitate to contact me if you have any question or suggestion for continue our work. Thank you.